want to do is, it has been 11 years since the Giza power plant was published. And since that time, there's been quite a bit of controversy that's swirled around it that really has driven me to actually go out and seek better evidence to explain my case in terms of the ancient Egyptians and their manufacturing capabilities. And what the Giza power plant contains is a chapter called Advanced Machining in Ancient Egypt. And that is actually what is going to be the focus of my next book, except there's more of it. There is much better evidence. And really, when it comes to evidence, with Egyptologists and traditionally the way they've explained how this fabulous civilization constructed their monuments, they will go out and actually start to demonstrate how you can cut granite using a dolerite ball or a copper chisel or a stone chisel. But typically, they are methods that are very primitive, and what my book shows is that they don't explain the evidence. And really, as a manufacturer, and there are manufacturers in the room too, when you're going to explain how something is done, you have to really know what it is that you're trying to explain. And a lot of the documentaries that we've seen over the years will show just little snippets of somebody bashing a rock, the unfinished obelisk perhaps, or drilling a hole with a copper tube, and they accomplish very little, and they really don't get into a real accurate description of what they are talking about. So what I'm going to show you, and I'm going to try and move this through quickly, is I'm going to show you the evidence as I see it as a manufacturer, and hopefully when we've moved through all of this, we can say, maybe they haven't explained that case. And but what I have is something that's quite startling, in my opinion. So the book that it's at the publisher now. It should be on the bookshelves in July of 2010. It's going to be published by Inner Traditions. It'll be about 432 pages. It's got about 280 photographs and graphics. So compared to the Giza power plant, and it's going to be in color. I'm hoping full color, but at least there will be color inserts. But what actually got me on this particular phase of my research was a trip that I made with David and others to Egypt in 2004. And we went to the Temple of Luxor, and I don't know if David or Bart noticed, but occasionally I would wander off and start to look at things and ignored the Egyptologist who was supposedly telling us about this ancient culture. I was looking at very, very precise granite objects. And when you go to the Temple of Dendera, it's immediately striking in that what we have are these giant statues. And the giant statues, there's about 4 of these that sit. There's of Ramses, 2 of them outside the temple and 2 of them inside the Ramses Hall, just inside. Here we see one on both sides, just got the arm there, but this one is inside the Ramses Hall. But you can see the size of them compared to the people. And they are made out of solid granite. The only separate piece from the statue is the plinth or the base that some of them are set on. But they're amazing. Now, one of the things that I really focused on was this particular head or bust that is sitting to the left of the obelisk. And essentially, what we have is an order of precision that you don't normally find on a statue. And you would think a statue is a sculpture. And I'm here to tell you that these statues are not necessarily sculptures, but they are engineered and finely crafted products. The crowns was actually what got my attention in 2004. And I was fascinated with these crowns because they had several of them sitting around the court, the Ramses Hall, and they were sitting at the base of the walking statues in that hall. And the crowns are actually what start out my book. Chapter 1 is dealing with the crowns. But what I'm going to do is give you, just a little bit of, just a snippet of information. Obviously, I can't go through the whole book. But I'm going to take a little bit of the front, some of the middle, and then we'll move to the end of the book. Now, how do they craft the Ramses head? In 1986, when I was at Memphis, and I wasn't really interested in temples, I was more interested in pyramids because that was the book that I was writing at the time, the Giza Power Plant. It was strictly engineering, and I didn't think engineering necessarily applied with the temples. So I didn't go to the south, and I didn't go to the Luxor temple or any other temples except what was at the Giza Plateau. But what we have with the Ramses head is an order, a design protocol that is quite amazing. We have a design based on the dimensions of the mouth that is like you can actually form a Pythagorean triangle. Well, we know the Egyptians, when they laid out a statue or any object, that they used a grid. And it's the same thing that we do today. We use grids. And so if you create a grid based on the Pythagorean triangle and matching with the Pythagorean triangle of the mouth, then you can start to overlay some of the geometries that we were working with. And what we see is, if you look at the circle, that is a true circle. And just looking at the right cheek, what we have is something that's quite remarkable for any machinist, because when you look at a radius, but it's not a two-dimensional object. This is a three-dimensional object. And so what they had done is created a precise radius that when you look at it in 2D, it's a precise radius, but it's moving in 3 dimensions. So it's moving X, Y, and Z. How do they do that? And it's the same on the other side. Now, going through the rest of the statue, we see that there are, again, we're working with the circle protocol, and we have these correspondences with the grid. Not just there. We have the eyelid, the lower eye, the upper eyelid, the top of the eyelid, the mouth, and all the circular geometry is tangent with the correspondence with the grid. And you see the points on the grid with the radiuses that actually make up the geometry of the face. So what I did then is, one of the things that I noticed about the statue at Memphis, when you go to Memphis and you look down the length of the statue, you'll notice that the nostrils are identical one side to the other. And that's one thing that struck me, because there is no person, no adult actually, who has identical nostrils. And if you don't believe me, go home and cock your head up and look in the mirror. They're not perfect. But Ramses were perfect. So I with the geometry, I thought, well, it looks perfectly symmetrical. Well, let's see just how symmetrical it is. So what you see here is a view of the Ramses, a copy that has been flipped. So you're looking at the reverse image of the same photograph. And then I made a transparency of one and brought it across the other one, and you begin to see how you see the shadow as it comes around the jawline. And then you can see that the jaw lines are perfectly matched. However, the mouth, you can see, is not matched. Well, there's one of the things about photographing a engineered product or inspecting an engineered product is that you have to be coaxial with the center of the piece. In other words, there is a true center where the mass of material is equal on both sides. Well, I was off just a little bit with my camera. And so I had to go back and actually take more photographs. In fact, some of the photographs that I looked at originally were a lot worse than this. And the one that I have in my book is actually better than this. But I don't have that slide on here. But you can buy my book next year and you can see it. But as you can see, the jawlines match, the nose matches, the eyes match, and the lips are just a little off. Now, it's my belief that the way they manufactured that was they created the shape of the face using the least number of geometric elements, because the face is so smooth, it's unnatural. It's almost like a cartoon face, just like I showed earlier. I mean, it's like a cartoon. When you look at the outlines of all the features of the face, it doesn't look like a real face. And if you don't believe me, go home and look in the mirror and look at your own face, and you probably notice that there are a few cracks and crannies going on there, especially those reaching advanced years like me, you know. I wouldn't know. So when we pull them out together, you can see the distribution or the offset on the nose, but look at the distance between where the shadow is. It's equal on both sides. So the shape of the nose, when you look at it, is identical from one side to the other. All I need is just a better photograph to be able to demonstrate that. But at least I can bring those photographs to those images together, and the nose, the outline of the nose matches perfectly. Now this is amazing stuff. I mean, you know, think about what you have to do to actually make that. I know we've got some machinists in the room, and there's one sitting over there, another one there, another one here. There's all kinds of folks who are actually keying into this because they understand that this stuff isn't done just blindly going at a piece with a hammer and chisel. Now let's look at the geometry of the profile. And you can see again that we have the circle protocol. Everything is kind of designed like it was, it's almost like it was designed in a computer graphics program, just using a series of circles or spheroids and blending everything together to come up with this perfect geometry. Now the jaw lines, it's so you have like when you're looking at the jawline, you're looking at a radius from the front, and you're also looking at a radius from the side, which give you three-dimensional perfection in both axes. And it's not just the one statue. This is another statue that's in It's in the Ramses Hall that has the same kind of protocol or the same kind of design elements to it. And I've also got in my book photographs of other Ramses statues, one in the British Museum and a couple of others, where they're all identical. And you wonder when you go through Egypt or you go from north to south and you look at a statue of Ramses, every one of them looks the same.
Quick question, Chris.
Yes?
The radiuses, are they in any, like a pyramid inch type thing, full inches, you know?
Well, everything is relative right now, because to take those dimensions would require some specialized equipment. Yeah, I'd love to get some a CMM, you know, and take it over there, but I don't think Zahi Hawass would allow me to do that if he knows what I'm up to. So then I start to look at the statue and say, okay, well, you know, a lot of times you can note whether it's the action of a machine by the marks that the machine makes. And are there tool marks? Is there a tool path? And there are several statues where those mistakes are still in the statue. And you can see on this particular one that there are what I would consider to be feed lines where a tool has actually passed along the upper lip down to the mouth and has left marks. The marks are still there. Can everybody see that? Is it visible to everybody? If not, it will be in my book, I promise you. A shameless plug. And also, there are tool marks, specific tool marks on a Ramses statue at Karnak, which I took with a telephoto lens, and it's almost like a wireframe photograph, wireframe drawing with the step over from one pass to another, but it comes right down the side of the face. And above the eyebrows, there's even indents where the tool paused above the eyebrow. So that's the Luxor research, just a little snippet of it. And now we go to, well, you know, the argument may be, well, we don't know how precise that is. I think just doing an analysis in the computer and working with the images, we can see that it's uncommonly accurate for a sculpture. And you know, I've actually consulted with sculptors, and we'll get into that a little later on. But the uncommon precision is actually throughout all of Egypt. It's not just in Luxor on the statue, but even in the Serapeum, where you have the perfection of these granite boxes. And I think some of you may have seen these images before, but the granite boxes in the Serapeum, there's over 20 of them, and the inside surfaces of the boxes are within, I would say, at least over a 12-inch length within less than a half a thousandths. The gauge I was using was accurate to within 1/10,000th of an inch. And so that particular gauge, you couldn't see any light shining through it. And as you can see, the square, that's a precision tool maker square with a 14-inch blade. And there is no light shining through. It's pressed flat against the lid. And look at the reflection on the underside of the lid and the reflection down the length of the blade. There is no aberrations, or it's a true reflection. It's a perfectly flat surface. And so the question is, well, how do they do that? How do Egyptologists explain this? Next, we go to the Giza Plateau. And the Giza Plateau, there are some very interesting blocks that most people just walk past and don't pay any attention to. But this one is a granite block that has a true radius on it. And along the crown of the radius, it's, again, extremely flat or very true. It's almost as though, well, I know my good friend Steve Garcia here, the last time I presented, he said, you need to be more assertive. They've got to have been machined. And I do believe that. But with Egyptologists, with science, you have push the envelope, and sometimes, you know, the envelope doesn't open. So this was a test that I performed actually in 2004. I'm not sure whether Bart took that photograph or somebody else. Did you take that, Bart?
Yep.
Thought you did. Courtesy of Bart Hess. And so this photograph is where I take a wax impression at one point along a radius where these two surfaces come. So you've got a contour surface coming here and coming up to a straight wall. So that in engineering they call that a blend radius, and that's where you transition from one surface to another. Normally you would use a beefy tool to actually machine that. But that radius is true along the whole length of the block and around. And that's another view of it. And so again, they're using a protocol of circles or tangent circles to actually create their geometry.
What is the broken debris there?
I'm sorry?
It seems like broken debris pieces that are scattered that you're showing these radiuses from right now.
You talking here?
Yeah, those.
Yeah, those are other blocks. If you walk the Giza Plateau, you'll find all manner of broken blocks all over the place. And actually surrounding this is just some really, really rough blocks. And this is just laying there, a total anomaly laying there that's extremely precise and obviously machined. This is a broken off part that actually broke off the other piece. And again, you have the same geometry on that piece. Next we go to, this is actually, I'm flipping from, going to Dendera real briefly just to demonstrate how the ancient Egyptians built their temples and used some architectural elements, such as these cornices on the top of their walls. Because at Giza, by the Valley Temple, is a cornice that actually must weigh, I think it would weigh about 16 tons, but it's very precise. It's precise in its geometry. It's also precise in the way it was, the way that geometry is projected down a line. And I'm using a 12-inch straight edge. That's the one that was ground within 1/20th the thickness of a human hair. And again, what we have is a tangent circles. But if you look at the bottom, you'll see that circle showed, that the image actually showed some material in this area right here. That's because the end was broken off on an angle. But if we look at that again, as you can see, you got some material there, but at the end, that is a perfect circle, and at the top, you've got a perfect circle too. So how did they make these? You know, did they actually go at it with dolerite pounders and wooden straight edges and squares? Well, what would we do today? We'd probably slap it on a CNC machine and replicate that contour along the length of the piece.
What's a CNC?
Computer numerical control machine. Essentially, you design the geometry in a computer, and then you generate what they call CNC code, which is machine code that goes into, you feed it into a machine and then execute a program. And the CNC machines or milling machines generally are 2-3 axes, or 2.5 to 3 axes. This would be a 3-axis machine. Some of them go up to 9 axes. And normally you would actually generate a wireframe and then model it and actually come up with the CNC code. But did it sit on top of a temple? Well, if you go around Giza, you don't find any other blocks like that. There's just that one and another little broken one off to the side. Certainly not enough that would say, yeah, that the temple wall was surrounded with these particular cornices. However, there may be another answer to that. And that is that there it is turned upside down. And if you get the other one that was on top of the Giza Plateau, the one that I was checking the radius, and that's on the other side, then you have some architectural elements that would fit very nicely over a doorway. This is the one that was on top of the Giza Plateau. That's at the Valley Temple. And combine them with some square blocks, and you have a very elegant and classic architecture for a doorway. Next we go to the unfinished obelisk. And the unfinished obelisk is a massive block, or it's actually still in the quarry, and it weighs, estimated to weigh around 1,200 tons. But there it is. This is an interesting object because when we examine how the ancient Egyptians actually created their artifacts, here we have evidence of a block in the quarry with the tool marks actually in the quarry. And what they did is they cut a trench. Obviously, they cut a trench around the block, and then they would have pried it loose from underneath.
Chris,
Yes, sir.
did you say that tool marks were evident on that piece?
Yes, and here they are. These are the tool marks that whatever tool they were using left in the trench. And the interesting thing about this is that the conventional theory on how this unfinished obelisk was actually quarried was that they used a harder stone, a little dolerite pounders, and they had 100 or so folks inside that trench just pounding away at the granite.
How many years would that take? About
It would,
1,000 maybe?
well, you know, it depends who you believe. My studies on this particular piece, there was a fellow in 1920 he wrote a book called The Problem with the Obelisk. His name was Engelbach, and he claimed that you could remove about 450 cubic centimeters per hour. Unfortunately, he's the only one who has actually claimed that. Another guy, Dennis Stocks, estimated that for using a dolerite pounder, he could remove about 32 cubic centimeters per hour. So we go from 32 cubic centimeters to 450 cubic centimeters per hour. And there is a huge difference between the two. Also, I don't know if anybody saw the documentaries with Mark Lehner and Roger Hopkins called Obelisk. There was two. There was one in 1999. The other one was in 2001. And Mark Lehner took his team out to the quarries to actually demonstrate how the ancient Egyptians were able to carve and move their obelisks. Of course, his evidence was very slim, and this is why he didn't really describe all the evidence that is actually on an obelisk, because if you look at the obelisk and you look at the deep incisions, they're about an inch deep, and they're very, very precise. They're unbelievable objects. He and his team created a circle that was very, very shallow, very, very rough, and they did it with a dolerite pounder and said, see, I do believe that the ancient Egyptians had a rapport with the stone. And because they had this rapport with the stone, that they were able to create all these marvelous objects. So, does anybody believe that? I mean,
It's really like the difference between somebody sketching something and somebody making a finished oil painting. It really is. That's the degree of difference there is. Or a finished engineering drawing. People can sit there and sketch up nice little pictures and say,
oh, sure.
That's a drawing. It
Yeah.
is not. There's so much more
Yeah.
that goes into it.
But the other thing is, in my view, is that, you know, there are some people who, actually John Anthony West, who said, when I went to Egypt with him in 2006, and, you know, he said, well, you know, the ancient Egyptians, it's like if you give me a violin, I can prove that I will create a terrible screech, but if you put it in the hands of a maestro, you're going to have beautiful music. But the analogy is false, because we're talking about forces, an energy that a person who is a maestro on a violin would probably expend less energy to play the violin than say me. And so the analogy doesn't work. In engineering and manufacturing, it's all about material removal rates and the capabilities of the tool.
You still talking granite stone now?
Yes.
Chris, are there differences in the machining between granite and limestone?
Huge. Yes, granite is an igneous rock, and it has this particular granite has 55% silicon quartz crystal, so it's much harder than granite. And you can use a stainless or a steel tool to chisel away granite limestone, but if you're going to work on granite, you have to. I mean, carbide, you can crush the material and remove it that way, but actually doing some really fine detailing and cutting, you need diamond tools. And you know, there's evidence that they actually use rotating diamond tools to cut some of their artifacts.
This obelisk was granite.
This is granite, yeah. And the interesting thing at the unfinished obelisk is that the calculations for how long it took are really trying to prove out the lettering or the description on the base of Hatshepsut's obelisk at Karnak, and that inscription says that the obelisk was crafted and put in place in a 7-month period. When, if you do the calculations using a constraint analysis, and depending on what numbers you're working with, even at 450 cubic centimeters an hour, you're not going to get that obelisk out in 7 months. And with Stock's numbers, it's going to take considerably longer, years, because you have to calculate from the deepest part of the obelisk and assume that there's only one fellow who's going to be actually in the trench pounding away. Then you get to these particular features, which nobody talks about, and you won't see them in the obelisk video because they're problematic. You can see Dan Hamilton down in one of these trenches or these holes, the shafts, in the trench. And looking down that trench, you can see that there are, it's almost like the tool that was cutting in a sweeping motion. You see the striations, you can see them on this wall here, but also around here. So
How far away are these from the Giza Plateau?
about 400 miles. And so the sweeping motion, there had to have been a sweeping motion of the tool to create these scallops. And the dolerite pounder, you know, that just kind of goes out the window.
Chris?
Yes?
You know Mark Lehner, and most of what you hear him say, he said that he's playing Hawas's game, otherwise he wouldn't be able to get in there. But on the side, he shows some of his own pictures.
Really, I'd like to have a conversation with him about
But
that.
he doesn't, he's not publicizing it now, he's just going along with
Yeah,
Hawas.
You can't go into
Otherwise, he wouldn't be in there.
yeah. No, I think you're absolutely right. I've met Hawass on a couple of occasions, and you're not going to, if you cross him, then you're not going to do anything. But, and I think too, you know, if you look at those documentaries, it seems that Mark is actually showing the world how it wasn't done, not necessarily how it was done. But if you look at the dolerite pounder, and then you look at these shafts at the base of that obelisk, you can see that you've got some square corners here. Well, you putting two and two together, I don't have to say any more. I'll just show the images. And then this is an unusual feature that I didn't even know existed, but a French production team took this photograph and sent it to me. But again, you've got the kind of a sweeping motion of the tool and these sharp corners here. Now the thing with material removal in the dolerite pounder scenario, they work with gravity, and all the writing on how the ancient Egyptians created these obelisks or quarried around these obelisks did not address the corners. And when you're actually working with gravity, you're dropping that ball or pushing, you're forcing that ball down in a vertical direction. And so gravity is your friend then. But if you get in a situation like that, gravity is definitely not your friend. It could be your enemy. And watch for your toes. But it was interesting though, Mark said that, you know, about the rapport with the stone. I thought, well, you know, I'm dealing with statues, I'm dealing with material removal, and I really should get the opinion of a modern sculptor. So I contacted a fellow by the name of Mike Leckie. And Mike Leckie does some beautiful work, and this is a marble, he calls it the bather. It's a marble statue. And I gave him, sent him some photographs and some text from the Ramses statue. And he wrote back to me, he said, well, thank you for this opportunity. I've been interested in Egypt and its sculpture since I was a child. As a stone sculptor, I can say that the granite of the Ramses head and figures is an extremely hard stone, and I believe tools much more durable than hardened copper chisels must have been used in the carving process. It would be necessary for me to upgrade my normal tools to carve such granite. My modern diamond blades and grinding points will be worn out before the head was even started. The ancient carvers must have had advanced technology. Although the ancient Egyptians had stone chisels and hammers which could cut extremely hard granite even with an army of disposable labor, completing 4 large sculptures alike, exactly with hand tools, would take more time than we can conceive of as possible. Modern man with all his modern tools would be challenged to finish one Ramses in a generous timeline. Creating 4 of them, as large as they are, all the same, seems almost impossible. But this is a sculptor. But it could be argued, well, they didn't work on these statues one at a time, one after the other. They had multiple sculptors. And I don't know about you, but if you know anything about sculpting, it's a creative process. And yes, the sculptor does build a rapport with the piece that he's working with. And they need that creative element, creative freedom. So I seriously doubt that a sculptor or a series of sculptures were crafting identical Ramses all over Egypt. This is another explanation. These are reliefs found on or paintings found on the tomb of Rekhmir, showing how the ancient Egyptians actually squared up and chiseled rock. And this is one showing them actually polishing or creating a Ramses statue. In the Cairo Museum, you have a case of copper chisels, and if you go there, talk to an Egyptologist there and ask them, well, where are the tools that built the pyramids? They'll take you to the tool room, and they'll show you two cases with copper implements in them. But it's the mistakes that really tell the tale, and the mistakes of the ancient Egyptians or the people who built these marvelous statues are undercuts on statues showing very, very small radiuses, they're true radiuses, and this was actually on the statue of Amunmut in the Luxor Museum, and there's an undercut of the buttock where it meets the bench. But now I want to get to, actually this is moving quickly to the last part of my book, and that is a response to my critics. I don't know, I mean, I look at a lot of surprises in the audience. Everybody's surprised that I would have critics out there, but I do. And one of the criticisms that I have received, or one of the arguments against my analysis of this particular piece, has prompted me to do further research that will settle the matter, hopefully once and for all. Not necessarily come up with the true explanation for how this thing was created, but at least disprove any arguments in the Egyptologist camp on how it was created. And this is a granite core. It was found at Giza by Sir William Flinders Petrie around 1981, and it now resides... 1881, sorry. And it now resides in the Petrie Museum at the University College London. When I had an article published in 1984, it's called Advanced Machining in Ancient Egypt, and I proposed, based on Petrie's account or description of this particular artifact, I proposed that they were using advanced methods to produce it. And the features of the core, as Petrie described it, was that it was a core that was tapered. It had a spiral groove that wound around the core, and it was a true spiral, except that it wandered around its course. In a subsequent paper from his book, he called it a drunken screw. But he said that the spiral, it was a spiral, and the distance between the grooves was about 1/100,000th of an inch, or 1/10 of an inch. Well, to any manufacturer or machinist, you would think that is an impossible feed rate, even in mild steel, but in granite, it's an impossible feed rate. So I puzzled over that for many years, and, well, not many years, a couple of months, but the solution that I came up with was rather controversial. In my article, I proposed that they were using ultrasonic machining. Of course, that didn't go over very well, but the article was published in '84. It lay dormant for a while. Then in 1995, a debate sprung up on the internet, on Deja News, And I was taken to task for my views, and I thought I defended them fairly well, but the matter still wasn't settled. Then in 1999, a book came out called Giza the Truth. And in Giza the Truth by Ian Lawton and Chris Ogilvie Herald, they actually located where this core was, took a photograph of it, and put it in their book and said, these are not spiral grooves, they're horizontal. Well, because Petrie had argued that they were spiral, I had based my theory on Petrie's information. Now we have a book that says, no, they're not spiral. These have been examined by us, and they're definitely horizontal, which means that the starting point of a groove actually ends at the start point. So their start and end point are circular. So then I took off to go to England to examine it for myself, and at an interesting time. But what I found was that in Giza the Truth, they had photographed the core, but they photographed it on an angle, and it wasn't trued up. And as you can see in this photograph right here, it's tilted. And even when I took a photograph of it, it was tilted. And I had to put a frame around it to square it up so that I would have an accurate view of it. But what I'm trying to explain is that if you take say a pipe thread or something like that, and you tilt it on an angle, the thread looks like it's horizontal. But when you true it up and square it up, it's not horizontal. And that's essentially what's going on here, that they have presented in their book a photograph of the core that was tilted on an angle. And so they got confused about the evidence. Well, I decided, well, the best way to actually check this out is to use a simple white thread. I see all the women nodding, yeah, all right. And so I placed the thread in the groove and put some tape over it, and then just started to wrap around it. I published that on my website, and people still didn't buy it. They thought that, well, you know, I'm fudging it. And then a geologist contacted me, Malcolm McClure, that's this fellow right here, and he was a geologist with British Petroleum for about 30 years, and he was interested in the Petrie core, and he was also interested in crop circles because he thought that those two were the only unexplained mysteries that had yet to be explained. So he was very curious about putting this one to bed. And as I was wrapping the thread around, I could sense that he was getting impatient. You know, and I said, well, Malcolm, you want to take the thread and do it yourself? And so he said, yeah. So he took the thread and he wrapped it around, and after he had finished about 16 winds, he said, wow, I'm speechless. So, but even that, I needed to actually be able to display the groove on this core in 2D. Well, you know, being a manufacturer, and we work with cones all the time, right, Greg? And essentially, we create these frustrums of cones. We lay them out flat, and we know that if you had a flat sheet and you had a spiral groove, you would have, or a circular groove, you'd have two reference points here and a line across there. Then that point, the start point, would be the same as the end point. And that would be a circular groove, which is what my critics are trying to say the core has. So on my visit in 2003 to the Petrie Museum, I asked the curator, Dr. Stephen Quirk, if I could have a latex impression made of it. And he agreed. I paid him cash, and essentially I got this latex peel a few months later, and this is it right here. So the logical thing to do then was actually to cut a couple of holes in it, because when I separate it, those holes would be my reference points. And so a couple of square holes were cut in it, and then I separated it out. Well, this is what the peel looks like. I mean, it's the granite. If you actually had it in your hands, you would see that a lot of the mica or biotite has been ripped out, and the groove itself wanders, just like Petrie said. It's like a drunken screw. But it is indeed, it does not have a horizontal, it's not a horizontal nature. So this actually shows it in 3D. He's looking at all sides of that core now for an analysis. And here you can see that the interesting thing about this is that those grooves are not shallow, and they are separate from each other, even though they do move back and forth. And the depth of the groove goes from 0 to 7/1000ths of an inch. I think that's the end of my Egypt talk. You want me to keep rolling on this one? Yeah, sure. Okay. It is a plug for David's DVD on South America trip. You know, David and I, David is a very excitable guy. He loves to talk, and so he said, "Come on, Chris, we're going to South America and we're going to look for advanced machining." And so we went to all the sites that he showed earlier. We went to Ollantaytambo, we went to Sacsayhuaman, Machu Picchu, Tiwanaku, and he said, "Okay, Chris, this is advanced machining, right? This is machine, yeah?" And I'd say, "It's a flat surface, and I need to see more." It's very precise, but it's still just a flat surface. I don't think, you know, I need to see more in order to argue that a machine was involved in it. My personal feelings were that, yeah, it is, but you know, having faced my critics for many years, I know what kind of arguments are going to be thrown my way, so I wasn't ready to sign on to the advanced machining yet. And then we went to Pumapunku. Poor David, I mean, he was so disappointed in me. Here he had his expert witness, and I wasn't giving him anything, which is why you don't see much of me. But when I went to Pumapunku, that was interesting, because this particular block right here had me puzzled. And it's just a rectangular standing block, but it has some very interesting features to it. I wasn't expecting it. And we had driven from La Paz out to Tiwanaku, and I'd left my suitcase back at the hotel in La Paz. And when I saw this, I'm like, oh, crap. I didn't bring all my tools. So I had to get our driver to take me back to La Paz, which was, I don't know, it took about 5 hours, and finally got back, and then the next day we're back at Pumapunku and taking some measurements.
Typical bathroom in that area?
Huh?
Or was that a typical bathroom in that area? They're nasty.
Yeah, it was. And this is an interesting piece, because there is a groove down the length of it with these holes drilled into the groove, inside the groove. And a lot of people think that these holes are actually equally spaced. They look equally spaced, but they're not. They vary. But the distance between this groove and the outside right here that I measured is within 10/1000ths of an inch from the top to the bottom. And I would say that, you know, if I had had better equipment, because I was just using calipers to measure that, the way to measure it would be to have a pin, or a dowel pin or a gauge pin, to lay in the groove and measure across the gauge pin. But I didn't have that. So that is quite a piece, and certainly one that I could say, I think they were doing something a little more than just bashing and simple kind of technologies. And even around this particular piece, you can see the shapes. It's almost like they cut into this, they just plunged into these blocks, creating square holes, I mean very square holes, very precise. And certainly I would say that we have some advanced machining or lost technologies in Pumapunku.
All those holes were square holes rather than round ones, so from this view it looked like they were round, until you said they were square.
Okay, maybe I should say square recessions. In other words, the holes, the round holes that I showed you were very small, about just over 1/8 of an inch. But the recessions are square, but I would say probably 6 to 9 inches. Okay.
What kind of stone is that?
That is a volcanic type rock. It's like a basalt, but it is a volcanic type rock. It's very porous.
Were the hole sizes the same?
Yes. I don't know to what tolerance they were the same, but yeah, they were the same. And the surface was flat. I mean, and the block was square. So, and then this other piece, which was a very interesting piece, also in the vicinity, but definitely looks like it came off a milling machine. But you look down here and you've got three surfaces coming together to a very, very sharp square corner. And again, these inexplicable holes drilled into it.
How deep are the holes?
I don't know. I didn't have the equipment to measure the depth. Sorry.
What is the dynamics of that particular site?
In terms of,
All we know is there's some stones on the ground. What was the dynamics of that site?
well, yeah, David addressed this earlier in his presentation, and he actually has showed photographs of archaeologists' reconstruction of the site. There have been quite a few people who have addressed what it might have looked like and what it might have been, including, I think, Eric von Daniken, right, David? But I was looking for machining particularly. I was looking for a very, very precisely cut stone that had the hallmarks of machining. And then, these things are very puzzling. What were they used for? Yes, sir.
On that block up there right now, on the right end of that, you've got that tab sticking out. To the left of that, looks like two saw cuts.
Very top?
Which one?
No, on the right side of that main block.
This thing?
Are those,
No, those are actually identical. They're identical to the groove on the first block that I showed you.
that's one groove?
Yeah, yeah.
That's not two separate saw cuts?
It's two separate grooves. I don't know that they were created with a saw, but it's two separate
They're
grooves.
very thin.
Yeah, yeah. It's about. No, well, it depends how wide your saw blade is.
Agreed.
Oh, shameless plug again. I think that's the end of my presentation. And, thank you. I appreciate you coming.